in a certain sense, file systems can hide all sorts of things. There's something called network file system, which allows you to treat files on a remote computer as if they belong on your own computer. And you can, I'm sure you can put a front end onto Git that does that sort of thing in an invisible way. So you make a request to the operating system for a file, and the operating system says, oh no, I don't have it. Oh gosh, what am I going to do? Hang on, it's available from that place. So I'll get it from that place, and I won't tell the user. All the user will notice is the delay. An operating system a file system ought to be able to do that sort of thing if that's what you want it to do. I know that on Linux, you can have file systems where you have one file system and part of it is stored on a solid state disk and part of it is stored on a rotating disk. And it's all one file system. So that's the sort of thing that file systems do. But instead of thinking, oh, we can do all sorts of clever and wonderful things with file systems, particularly if you write more code, Git is a content addressable store, and it's a peer-to-peer distributed file system. So we could just use that as a piece of advanced technology, even though I think it actually is 21st century technology rather than 20th century technology. But if we just made more use of that, I think we were immediately working from a better platform. My preference is that before tech starts to compile a document, it should be able to say, yes, I've got everything it needs, or no, I haven't got everything it needs. There shouldn't be a surprise in terms of a missing package partway through a document. But that's my preference, that sort of come from my work as a Python programmer. You know, sort of the idea that you get a sort of runtime, I don't have this package error, is something that is a sign that you've not prepared properly. However, for users who just want to get the job done and don't care about theology, if they say use package so-and-so and they ain't got it, why don't you go off and get it? Although I must say it does provide an attack vector, doesn't it? I've rattled on for too long.
All right, so I have a question. I'm a little confused when we keep talking about content addressable being something that I'm not quite sure what problem is being solved by having this Git-based content addressable means of accessing a file. And the reason I ask that is because the way that tech works right now is you give it a file name, it farms it out to a file finding library, which in almost all cases has read in a database of where all of the files in TechLive are and hashes them, and you can look the file up to where it is just based on the name that's provided. And of course, the design of tech is that these file names all have to have unique and fairly short names. So in a way, it doesn't matter because the files can move around and then they're placed in this database that's read in by the search library and on every invocation. So what is it about content addressable files? What's the problem that's being solved?
Okay, the problem that's being solved is, have I got the same file that I used last time or that somebody else used? Have I got the same tree of files? So in a content addressable store, every object has an address, which is what's called secure hash. And an object might actually be a tree. So you can have a tree that has a secure hash. And then in Git at the command line, you can say, give me the object where we use this secure hash as the root of the tree, and then follow this sequence of folder slash folder slash folder slash file as the object I want to retrieve. And if you stop at a folder, you get a directory rather than a file, but the directory is just another sort of object. So in GitHub, you can visit a file. In GitHub, you can visit, they have URLs. The first part of the URL is GitHub, of course, but then pretty soon you get this thing that's obviously this secure hash, and then you get a path from there, and you know that that URL will always give the same content. So it's a way of guaranteeing that when you ask for something, you get the same thing. That's the magic. So the magic is that you can't fake the secure hash. So if two things have the same secure hash, then they are the same, or rather, it's more likely that the sun doesn't rise tomorrow than they're different. So but that's going into the statistics of that. Do you want to go?
So is this a solution to the problem of installing tech, or is this a solution to the problem of running jobs on tech? I think there's a distinction there that I'm not quite understanding.
Okay, it's a solution to both. The secure hash provides a solution to, have I got the same stuff? The secure hash is the key to producing a reproducible calculation, because calculation has inputs and outputs. And in a content addressable store, the inputs live in a folder called input, and the output lives in a file called output. And both of those things have a secure hash, and that's a point on the graph of the function that is the calculation. So what goes in has a secure hash, and the secure hash represents faithfully the object that comes in. And what goes out, again, has a secure hash. So we can check that two compilations of tech give the same inputs, have the same inputs, and have the same outputs, simply by comparing the secure hashes. Now, in terms of updating things, instead of changing files on a disk, what you do is you keep all the useful possible values of a file in a content addressable store, and then you produce a tree which has got its own address, and you say, that's the new installation. The new installation has this address, and the old installation has that address. And you can produce a shorthand, TechLive 2020, TechLive 2021, for this tree and that tree. But from a certain point of view, those two trees are specified by their secure hash, and they, so to speak, coexist. And the parts of them that overlap and are the parts of them that are identical are not duplicated. That's one of the great things about content addressable store, is that you don't need two copies of anything ever. So if you've got a 1 gigabyte tree in storage and you change 1 byte in one file, the additional storage required by Git is in the order of hundreds of bytes. You simply have the same tree structure as before, but the secure hash values all the way through are different. So branching is very, very cheap. Branching is cheap unless you change the thing you branch. And when you do change the thing that's branched, it's still cheap. And not only is the branching cheap, but the communication of the branch is cheap, because you only have to communicate what's changed. And essentially what's changed, when you change one file, that's the change in the file, plus the change in the parent folder, the directory there, and then the change in the parent of that, and so on, all the way up, cascades up to the root. So when you make a change at the base of a tree, you get a change that cascades all the way up to the top, and then you get a different secure hash number. And essentially all you've changed is 20 or 30 secure hash values. So it's not expensive. And if the text system gets the objects directly from the Git store, they don't even have to be put onto disk. But that's a question of changing the operating system or the way in which things are gotten. Arthur will know about the OPI, Open Press Interface, whereby in the early days of the Mac and stuff, you didn't want to preview the graphic using print-ready graphics, but you didn't want to go to press with preview graphics. And there was something called Open Press Interface, which is structured comments that said, well, here's the preview that you show on the Mac, and here's where you will find the big one for when you go to print. And Git sort of does a similar thing in terms of changing files and so forth. But it's a question of, do you do this in the operating system or you do it in the application? And sometimes you have to do it in both. I sort of answered your question, Doug. I'm afraid I've given you a bit of a earful.
Somewhat, yeah. You know, I mean, I'm coming at this from sort of a low-level nuts and bolts view of how, you know, how to find files to pull in and interpret, and I'm just trying to wrap my head around a lot of stuff that you've been discussing, so that's fine.
Let me try a different approach, which is, oh, Arthur, you had your hand up.
Jonathan, I'm getting a picture that the method that you're proposing prioritizes the small size of the installation, or perhaps the small amount of data that has to be transferred in order for a person to get their job done, tiny tech. And I'm wondering now if I were operating in that regime, and I, for instance, looked at the difference between Tech Live 2020 and Tech Live 2021, and I said, oh, I think I'd like to use the latest version to typeset my paper. And I'm relaxed about knowing exactly the versions of the various files involved. Like, for instance, I know one of these packages has been revised. They fixed a bug. I'll just trust them and go with that. What would be the impact on me? Would I simply say, let's go with 2021, even temporarily, and then that would be as much as I'd have to put my oar in the water, as it were, and then just wait for my computer to reconcile all these different files that now need to be updated? In other words, how transparent would it be for me? Or I'm worried that perhaps I'll be burdened with having to manage these secure hash values specifically. I have users who depend on my consulting services. That would be excessively challenging for them. You understand where I'm coming from here, I think.
The secure hashes are for computers to use. They're the names of the files that Okay, there's a big difference between variable data and fixed data, constants and variables. X is a variable, pi is a constant. Pi is always the same. And at the same time, I didn't say 3.14 whatever, 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 or I didn't say the sum to one and from 1 to infinity or whatever. When I said pi, I used a name. So there's a name pi and there's a value pi, and the two are associated with each other. And in computing, what I would like a situation where humans use the human name and computers use the computer name, so that when the person has a problem with their document, you're told both the human name of the format they used or the resources they used, and also the computer name. And that lies at the root of the design and purpose of version control and Git. The whole purpose of version control is so that two people at different times, at different places, on different machines can have exactly the same data. And that lies at the heart of tech, which is identical inputs produce identical outputs. And that statement is useless unless you have a means of saying identical. And isn't it bizarre that to show that, you do a tech job and you don't like the PDF that comes out and you want to make a complaint. So you send the inputs and you send the outputs. Well, why do you have to send the outputs? Why not just send the inputs and give the secure hash of the outputs? And then the person can run the thing. And if he gets the same secure hash for his output, he knows he's got the same file as you have.
Well, I think that would bear on this make process that TechShop uses to determine whether it should repeat the tech run.
Yeah.
LaTeX notion of just rerun LaTeX n times, and pretty soon everything will settle down. I saw Doug's hand up. Doug?
So when you run tech and it creates say a PDF file, is the date of the run incorporated into that PDF file? In which case every PDF output is going to be different?
You can fix it so it stays the same. I think there's a command line option or something that says use this as the date of the run. The data of the run is sort of metadata, and different people have different views about putting metadata in output files. On the one hand, it's convenient, and on the other hand, it's a pain in the anatomy. I don't want to sort of have the focus on what will happen in 10 years' time. I'm sort of interested in the focus of how can we make things better in a year's time? How can we make TechLive 2022 better, or at least easier? How can we make TechLive 2022 better or easier? And if all the tech distributions had a shared view as to how fonts were to be handled. When I say that, I mean the distribution of the fonts. So there's a folder called fonts, type 1 fonts, that contains all type 1 font data. And every distribution has the same folder. I think that would just be an enormous advance if every distribution had the same folder for type 1 fonts. Because you wouldn't have to, what's the word? Update is simply adding to existing files, assuming fonts don't change. And if fonts do change, then blimey, you want to know about it.
So I think the point you were making, oh, I'm seeing Nelson's hand. Nelson, why don't you unmute and go ahead and speak?
So there's one point here we're overlooking something. In the traditional tech world, where tech handled the complete set of decisions of where glyphs go on the page, then having checksums and everything really allows you to determine that you have identical runs on different computers. However, with the advent of Unicode and more complicated typesetting requirements, notably that some Asian languages, notably in India and in Southeast Asia, have a practice of rearranging letters in a word when the word is placed into a display format for a view on a page or screen. And the way Luotech and Xtech work is by calling that underlying font library for Unicode. Say, here's a word, give me back information about where each glyph goes. Now, the problem is that library is system dependent, and there are three completely independent implementations. Apple has one, Microsoft has another, and IBM created a third, which is what people in the Unix world, including the Linux family and the Solaris family and the BSD family, all use. And one of the things this means now is that in a system update, that Unicode library layer can be changed, and your typesetting is now different. And all of your protection with checksums is for naught because you haven't checksummed the underlying libraries and you have no control over them, and you can't get back a previous version either because the vendor has just forced an update on you. As I started this Zoom session today, Windows popped up a note that I need to update your system now, but fortunately there was a button that said I could do it later. This goes on incessantly, and it is a big, big problem. So we do have to recognize that there are going to be situations, particularly with complex fonts, where tech itself cannot guarantee the same placement of glyphs from run to run. And that means page breaking and line breaking and indexing all change.
Well, I didn't know about that. I'm horrified.
That's quite the bomb.
It is. Now, it's true that for fonts that don't require this complex font handling, where you're just doing a character at a time, if you stick to plain tech or LaTeX or PDF tech, you're fine. But as soon as you step into the world of Luotech or Xtech, you're not fine. And I've warned users, and I document on our thesis website that you have to be aware of this issue, that the decisions about how words are put together from glyphs is dependent on an underlying font library that differs from platform to platform and you have no control over. And even when it's from the same source, for example, we deal every year with the IBM font library, LibICU. That changes from year to year, and it causes us grief at times when things fail to compile. So it's a thing we have to be aware of. The goal, and that's why I mentioned earlier that if you really need reproducible document formatting, you really need to capture the state of the entire machine. And a virtual machine provides a very good way of doing that, because I think we have pretty good confidence that a virtual machine created today will continue to run for decades into the future. We've gone back into computing history and we've created virtual machines for pretty much almost all of the architectures that have been used in the commercial computing environment. And you can now run a 1950s or early 60s mainframe in a virtual machine. It runs much faster than it used to, and you can reproduce the results that you would get some 60 years ago. And perhaps I should add that most individual users probably don't care very much if their typesetting changes a bit from run to run. But in the publishing community, this is quite different. Publishers really need to be able to reproduce the exact appearance of a document, whether this is a scientific journal or a legal document or a set of government regulations, and it must be exactly the same as before. This is one of the reasons why the letters of A and X and U and so on have been attached to various PDF specifications to try to get a complete single file that represents the document the way it was originally produced and will eternally be reproducible. Now, you may not have the tools to recreate that PDF file, but you must be able to render it, get the same results every time.
I'm reminded that, Nelson, that PDF is a page description language, DVI is a page description language, but TeX is not. I don't think the intention was for TeX to be a page description language. So there's a tension, I'm aware, that's present here. Not sure I can define what it is, but I recognize that we often take for granted that a page description language has entered the picture, and we don't really recognize clearly the role it plays, whereas text markup has an aspiration articulated by Donald Knuth that there would always be a tech engine that would produce the same results from my source files well into the future. So, well, he said forever, right? I see that level of stability as itself having a benefit, but it exists at a level that's different from the page description language.
Yes, I mean, we certainly have this problem, but governments are facing an issue that if electronic representations of documents are to replace paper printed documents, they have to have a way of guaranteeing that a document viewed today is identical to the that same document viewed at an arbitrary time in the future. This can be incredibly important for legal purposes, criminal cases, financial cases. There have been court cases that were decided on the interpretation of commas in particular statements. And so minor things, we don't think a comma is very important, but it can actually change the meaning of text. So it's important that we be able to produce documents that have a constant meaning.